Yeah, adding on the outside is up, subtracting outside is down.
Okay, so word of caution here. What happens is, last time in one of the classes when I was recording the video, I recorded it as slow-mo. And that became a horrible experience. Like for the kids, the 1 hour video became a fire video, and I noticed that only after I uploaded it, I had no option of converting a slow-mo to a regular video. So that happens. But anyways, for today, we want to talk about geometric transformations. But before we do that, there are a couple of things. So what did we cover in the last class? We talked about basic geometry. We talked about shapes like triangles, quadrilaterals, and every shape that you talk about. Let's say you talk about a line segment. I would not want to bother about each and every thing relating to line segment. I would only bother about the two endpoints, because that is what is constructing this line segment for us. And I'll tell you why I'm blabbering this one. Okay. If I'm talking about a triangle, this is actually comprising of three endpoints, these three corners that you see. As long as I'm able to locate these points, I'm fine. These 3 points can move to this place as is and will make the same triangle. So what I'm trying to say here is, when you're looking at any shape that is comprising of certain endpoints that describes the shape. If you're looking at a triangle, you're looking at these 3 points. You're looking at line segment, you're looking at these 2 points. If I'm looking at a quadrilateral, I'm looking at these 4 points. That helps me describe the shape that we are looking at. Okay? Now, and you guys are comfortable with the area of triangle, area of quadrilaterals, area of a circle? How much is area of circles? How do you get
2 pi square.
pi r square?
Or pi r square.
2 pi r is the perimeter or the circumference.
Yeah.
Similarly, compound objects, if I talk about, what is your understanding of compound objects? What is the compound objects?
Oh, like it's made out of different shapes.
Yeah. So what we know is the simple shapes. And close the door. Right? It's a little noisy, and also it's allergy season, right? So I don't want you guys to. So we know about the ways to find out area and perimeter of regular shape, be it a triangle, be it a rectangle, be it a trapezoid, be it a kite. We talked about area of kite and trapezoid, right?
Oh yeah.
We talked about area of rhombus also, right?
Yeah.
Diagonal 1 to diagonal 2 by 2, right? So okay, so these shapes you can find out the area. You have the formulas also that if you remember, you can do it. Otherwise, whatever we have talked about, you would be able to relate to it. I say find out area of this guy. There is no formula that exists, right? So how you go about it is, you will look at, this is called a shape which is not a simple shape for sure. What you can think about is, let me join the corners. What I have a triangle, another triangle, and a trapezoid. So a shape which is made of combining couple of shapes, that is what is called compound objects. So you don't really have to bother about finding out the formula for this shape. Somebody gets even more mischievous and makes a shape like this and says find out the area of this guy. You will say, don't worry, I will break this into simpler shape that I know about and find out the area of this guy, this guy, this guy, this guy, add them together, that is my total area. I don't have to freak out for calculating the area of a shape which is coming from some other planet. So that's a compound shape. So I just wanted to touch upon that. Now let's talk about geometric transformation. And we are probably few weeks, or maybe 1.5, 2 months away from where I will not bother you guys with this dumb screen. This is very much old school. I'm planning to replace it with a digital screen where I will be able to play a little better with the thing that I'm trying to explain you guys. So deal with it for a few more weeks. Now let's start with the triangle. I have this triangle. Okay. Let's say this is my coordinate plane. Assume that I'm just moving the triangle from this place to this place. Or I flipped it. Or I fixed this corner, rotated it. Or you will see me playing with things, okay? Because when it comes to math, I literally play. I love playing with math. Now, I'm saying, okay, let me take a picture of this on my phone and zoom in, zoom out. So, I took a picture of this one, I zoomed out. I'm seeing a miniature of my triangle. I zoomed in. I'm seeing a bigger version of the triangle. All these things that I was doing here, let's say this was A, this was B, this was C, this was D, this was E, this was F. If you look at A, B, C and D, A, B, C and D, what am I doing? I'm here rotating it, fixing this point. Here I just shifted it. Here I took a mirror image of that across the x-axis. Let me do one thing. Let me take a mirror image of that across the y-axis also. I took a mirror image. I treated this y-axis as a mirror. I'm seeing a reflection of that this side. Here I took x-axis as a mirror, took a reflection of that here. So let me add this as G. In the case of A, B, C and D and G, I did not distort the image. I did not distort the object. I kept the size same. I just moved it. But if this was 1, 2 and 3, here also I have 3 sides 1, 2 and 3. I did not change the dimensions. I just moved them. Here I rotated it, here I took a mirror image, here I moved it, here I am taking a reflection. These are 3 variants of transformation called rigid transformation. Meaning your object is rigid. Your object is not changing. Let's take the example of your teacher. You guys are not liking the way I'm explaining things. You want to take revenge. You moved me to this corner of the classroom. You are moving me. I am still the same teacher. I am looking exactly the same. My height, my dimension, my width, whatever it is, remains the same. You're not liking it. You move me to that corner. Okay, that is not enough. You flipped me upside down. My head is down, legs are up. I'm still the same guy. My dimensions have not changed. My shape of my face is still the same. This is called rigid transformation. You are transforming the object, but you are not going to change the dimension. You are just looking at it from different angles. That's it. This is rigid transformation. This is the first flavor of transformation. Now look at C, E and F. What is happening here is you are changing dimensions. Here from A you came to E, or A you went to F. Here this became smaller in size. You zoomed out. If this was 1, 2, 3, this probably became 0.1, 0.2, 0.3. Here when you zoomed in, it became 6, 8, 10. You are changing dimension. This is called dilation, where you are scaling down or scaling up. Yeah. So when you look at scenarios when the dimensions are not changing, those are called rigid transformation. Why rigid? Because the dimensions of the object that you are transforming, their dimensions remain the same. Same thing with your teacher also. You were not able to change my dimensions. My hands did not become longer or smaller. My legs remain the same. Even the size of my glasses remain the same. Yeah, these are rigid transformations. When the object is rigid, that's why it's called rigid transformations. Now, in case of dilation, you are scaling up. Here you scale down. Here you scale up by a certain factor. Let's say you scale down in this case by 0.3. So this 1 will become 0.3. This 2 will become 0.6. So 0.3 times of the length, and this became 3 into 0.3, that is 0.9. So you have scaled down by a factor. Here you scaled up, let's say by 3 folds. So this became from 1 to 3, this became from 2 to 6, this became from 3 to 9. You multiplied every dimension by that factor. This is called dilation. This is called non-rigid transformation or dilation. Now there's one more thing that you would want to consider. That if you're talking about non-rigid transformation or dilation, if I, let's say, dilate a triangle, meaning I zoomed out, it will become a triangle only. It will not start looking like a circle. The shape remains the same. In mathematical term, we will say it's just a miniature of the same shape. What is not changing is the angle. See, this angle, whatever was the angle, that remains the same. This angle remains this angle. This angle remains this angle. So your sides are changing, your angles are not changing. Because remember, if I had an equilateral triangle and I dilated that to become a isosceles triangle, that is not going to happen. It will remain an equilateral triangle with a smaller dimension. That's it. So what it means is your angles are not changing. Be it any shape for that matter. If you squeeze a trapezoid to make it small, or you are scaling as you are zooming out to make a trapezoid look smaller, it will still look like a trapezoid. The angles will not change. Make sense? So when it comes to geometric transformation, these are only two flavors that you need to be aware of. One is rigid transformation, one is non-rigid transformation or dilations. When you talk about rigid transformation, your dimensions don't change, they just move. Now let's look at an example. When you're talking about dilation or non-rigid transformation, that is when you see the sides are becoming smaller or bigger depending on whether you're zooming out, zooming in, scaling down, scaling up, but your angles don't change. Now, the kind of questions that you'll come across. Let's say we did enough of triangle, right? Let's look at another shape. Let's say I have a rectangle, a square. Square rectangle. Doesn't look like either of them. So let's say I have a rectangle. Okay? This has coordinates 4, minus 8, 6. This is minus 4, 6. This one has coordinates minus 4, 8. This one has coordinates minus 8, 8. Okay, this was my. So now why I'm talking about coordinates, because coordinates are my way to locate any point on the coordinate plane. Right? So if I'm looking at a rectangle, I'm essentially looking at the 4 points which are defining the corner points of the rectangle. Now people will say your rectangle is transformed. There is a rigid transformation we are talking about. This point has a coordinate, let's say minus, 6, 6. Find out the other 3 coordinates. How would you find it out?
You see the difference between the
Exactly.
images.
So it's a more of a visual, intuitive thing. You have this point 8, minus 8, 6. So x coordinate is this one, y coordinate is this one. Here y coordinate is not changing. What has happened? This moved from minus 8 to 6. That means it moved by 8 points here and 6 points here. So total movement is 14 points. You will look at every other point. You'll say, okay, so if this guy has moved by 14 points, this guy will also move by 14 points.
10,
So
10,
it will be 10,6. Now, what you're doing is you're taking this point as a reference to find out what is happening to other points. So there's only lateral movement along the x-axis by 14 points. That's it. So everything moves along the x-axis. Only your x-coordinate is changing because your y-coordinate did not change, right? So you're only concerned about what is happening to my x-coordinate because your y-coordinate is fixed. There could be scenarios where you have an object like this. It came here. Okay? Then what you will see is you will take one point as a reference and see this point came from here to here. So there are two-dimensional movement. Along the x-axis this many points, along the y-axis this many points. Once you find out, let's say this was 10 comma minus 10 comma let's say 8, and this point has the coordinate 20 comma let's say 7. This cannot be 8, this is minus 8, and this is minus 15. So your obvious reference is, okay, if I fix these 2 points, I would want to figure out what has happened with respect to the movement. This is still a translation or shifting, whatever you call it. You are moving by certain units along the x-axis, and then you are moving certain units along the y-axis. Once you find out that whole thing, everything else is relative. So once you have these points, you look at what is my total movement, and then you can determine this. Yeah. Now there is one more thing that now I have given these dimensions. Okay, I mean these coordinates, and you are going to find out what happens to this guy. And if somebody says find out the length of all the sides and find out the area, you're going to find it out, right? You are saying that okay, my y coordinate is fixed. That means only x value is different from here to here. So that is total 4 units. Here you are saying my x coordinate is fixed. Y is changing from 6 to 8. So this is 2 units. Yeah. Now I don't want you guys to deal with easy problems. I want to complicate everybody's life. Yeah? And then simplify it by easy concepts. So I have a rectangle with coordinates minus 8 comma let's say 4. This coordinate is minus 2 comma 7, and this coordinate is minus 3 comma 12. I'm saying it's a rectangle. Can you guys find out the area for this guy? No, I'm doing it for a reason, okay? I'm not trying to bother you guys. I'm trying to figure out how will you relate to it. Earlier question is about horizontal one. You saw, okay, my y coordinate is not changing, so my only length is the difference in the x coordinate value. That's all. I don't want you guys to be happy. I'm trying to bother you guys. How do you find out the length? I mean, see, basically, if you have to find out the area of a rectangle, this is how your brain will process it. Okay, I have to find out area of a rectangle. How do I find it out? Length times width. Do I know the length? Not yet. Do I know the width? Not yet. How? How will you go about it?
Find the distance between the 2 poles.
How? That's the question. And I'm asking for a reason. I'll explain it to you guys. Don't worry about it. And you guys think about it. I'll just go grab the water bottle. I'm giving you guys 20 seconds.
That was not 30 seconds.
Not for this guy.
I think we should have 30 minutes.
Okay, go ahead, think. So see, I can give you guys a ready-made solution for this in 10 seconds, but I don't want to do that because I want you guys to think and decode a lot of things by yourself. That is what will help you in any stage of your learning experience. Yeah.
Take 6 to get to the x point and 3 to get to the y point. I don't know what you're supposed to do with that.
Okay, so there's something called distance formula. There's something called distance formula. If you are in a coordinate plane and you know the 2 points, you can find out this length by using a formula called, let's say this is d. So d equals the square root of difference of the x coordinate. So let's say this is my end point. So minus 2 minus 8. This whole thing is squared. Or let me write the generic form. So distance between any 2 points is difference in the x coordinate value squared plus difference in the y coordinate value squared square root. And now you guys must be thinking that, okay, you yourself told that I don't believe in giving formulas. Why are you forcing us to memorize this? And if I ever do that, that will be the most dumb thing I can ever think of. So I never tell, okay, this is a formula, memorize it, use it. No. Now let's decode it. I have 2 points, okay? These 2 points. This is, let's say, x1, y1, these are the coordinates. This point has coordinates x2, y2. Yeah? If I am saying this is x1, y1, meaning the distance from here to here, this is x1. Distance from here to here, this is y1. That's why the coordinate is x1, y1, right? Similarly, distance from here to here is x2. That's why the x coordinate is x2. And distance from here to here is y2. Yeah? Now I'm saying find out this length. You know the 2 points? Find out this length. Now, what will I do is, let me draw the perpendicular and break it down. So this whole thing becomes a right angle triangle for me. What is the length of this side? This distance minus this distance. So this distance here to here is x2 minus x1. Right? This was x2 and I minus x1 from that. That's what gives me this distance. What is this distance? Here to here was y2 and this one was y1. So this distance is y2 minus y1. Yeah? Now you and I have a common uncle called Mr. Pythagoras. He had given a theorem called Pythagorean theorem. Do you know about it? What does Pythagorean theorem say? If you have a right angle triangle, this is A, this is B and this is C, A square plus B square equal to C square. Or sum of the squares of the 2 sides making 90-degree angle is equal to square of the hypotenuse. Now we have the same thing here. This is my A. Let's say this is my A and this is my B. So A square plus B square equal to C square. This is the distance that I was trying to find out, right? So C square is equal to A square plus B square here. What is my A? This one. X2 minus X1. Square of that. What is my B? Y2 minus Y1. Square of that. So that means this C is nothing but square root of x2 minus x1 square plus y2 minus y1 square. This is exactly what the distance formula is. Summary of this whole gymnastics, drama, whatever you call it, whatever I was doing here. Yeah? So, summary of all that is, if you have 2 points in the coordinate plane, the absolute distance between the 2 points would be, you can find it using the distance formula. Now come back to this one. Okay? So you are trying to find out area of this rectangle. And you guys were thinking that, okay, why are we even talking about this? We know area of a rectangle is very easy to find. But we are compounding that with our understanding of the new thing called distance formula, so that if you just know the coordinates, you can find out the other properties. So here, I think distance formula is also there in the syllabus for you guys, if I'm not wrong.
Yeah, but.
Yeah. Yeah. So distance formula, though it might sound like something coming from outside, but it is whatever we know with respect to coordinate plane, whatever we know with respect to how you construct a shape. This just tells you how would you find out the dimensions. How would you find out the distance between any 2 points, and that gives you the dimension. Now if I'm trying to find out area of this guy, I'll say if this is, let's say this is length and this is width. So length will be equal to square root of the difference of the x coordinate between these 2 points. What is changing here? This was my end point, minus 2, minus the first one, so which is minus 8, square of that. Second point minus first point, difference, square of that. Yeah? Plus difference of the y coordinate value. So my y coordinate changed to 7 from 4. So 7, this is x2, y2 minus 4. Here I put that in parentheses because I had a negative sign, right? I just wanted to make sure that we don't get confused about it. Yeah? Make sense? No? 100%?
Yes.
Okay. Square of that. See, this became minus 2 minus into minus becomes plus. Minus 2 plus 8. Square of that plus 7 minus 4, 3. Square of that. So this became minus 2 plus 8 is 6 square, 36, plus 3 square is 9. 36 plus 9 is 45, square root of 45. Okay. If it was 47, that would have been a perfect 7 as a length. But this is 45. And again, I did not choose a question which gives you a perfect square. That's why I'm just doing approximation here. I'll say, wait, 6 square is 36, 7 square is 49. Maybe this is 6.8. I'm just making it up, okay? Now, same thing you will do for this distance also. You went from here to here. So this is your x2, y2, this is x1, y1. Doesn't matter if you are thinking this one is x2, y2 or this one is x1, y1. Ultimately, it's a difference. Square of a difference doesn't make any difference. Look at this. 4 minus 3 square and 3 minus 4 square will give you the same value actually. Okay? 4 minus 3 is 1, square is 1. 3 minus 4 is minus 1 square. Again gives you 1. So whether you are treating this as first point and second point, or this as first point, this as second point, doesn't make a difference. So don't burn your energy thinking about which one to pick. Okay? So from that you will find out this distance. Now after that circuits play. You know, once you have the dimensions, you can find it out. Now the question is, how does it relate to the geometric transformation we are talking about? We just learned a new concept in between, which is distance formula. Now, can you guys give me an example? How would this help? Think about it. More you think, more equipped you will become.
It helps you know if it's a rigid transformation or dimension.
Exactly. If you have, let's say if you are totally blindfolded, you are given this rectangle and you are given this rectangle, which is little misleading. You don't know. Again, it has more to do with my drawing skills, which is horribly bad. But imagine you are given only this coordinate, this coordinate, this coordinate, and again the rectangle is not lying horizontal, it is drawn like this. And you have no clear confirmation of the question saying you have the coordinates are given to you, but you are not seeing a straight relationship here. The distance formula will tell you how much is the dimension, how much is the length of the side. And then, as you rightly said, you would know whether it's a rigid transformation or a dilation. Yeah? So we talked about what are the different types of transformation, rigid transformation and non-rigid transformation or dilations. We related that with the distance formula because that will be your savior when it comes to figuring out the dimension of any distance between any 2 points if you only know the coordinates. because things will not be crystal clear just by the outlook of the question. Okay? There will be sincere attempt put by the teachers who setting the question for you guys to get you confused. Okay? And you will have to come out of that by supplementing your conceptual understanding of things. So, kids say no, geometry is difficult. I say it's not. Because geometry is probably one of the mathematical element where you have a picture also in front of you. It makes it more intuitive. Right? I mean, no matter how illiterate I am, these two are not same for me. If somebody writes 2 paragraphs here, if I have to read that to interpret something out of it, it is more, no, it needs more intelligence, how to understand, interpret. But here I don't need any interpretation. It's obvious. These two are not same object. Somebody says, this rectangle is similar to this guy, I'll say, okay, take a break. Yeah? I'll take a hike, whatever you guys say. Yeah? So, what I'm saying is, geometry, while it might sound that there are a lot of deep concepts in it, but they are not as difficult as long as you know your basics are strong. So we talked about rigid transformation, non-rigid transformation, and in the rigid transformation we talked about shifting, where we saw movement. That is called translation. When you are moving object from one place to another object, just by shifting it, it's called translation. When you are flipping it upside down, it's called reflection. When you are rotating it, let's say you had this one, you fix this point and then you rotated this rectangle. You rotated this one. Or you will say, I have a center here, I am attaching a string to this one. And then I am rotating it around this one. So your rotation could be rotation around a point or rotation around a center. Let's say if this is, I know this is not the right example, but let's say this is the string and I attach a rectangle here. And imagine this is the coordinate plane. I am rotating this triangle which is lying here at the bottom of this one, right? So you can rotate your shape around the center. Center is fixed here. Or you will say, no, I don't want to tie it to the towel that my teacher was showing me. I will rather rotate it here, depending on whatever question you are dealing with. So those are the rotation, reflection and translation. And then non-rigid transformation, that is where you talk about dilation. As long as you know how your dimensions are changing, you're fine. Now, we'll go to the next topic, okay? Because I'm in a hurry to teach you guys a lot of things before, as much I can teach from a concept point of view. Yeah. So that when you come across the exam, right? I know we have very little time for the next attempt that you guys are going to give. So we'll see whatever concept we can accumulate before that. But before I move to the next topic, I want you guys to practice few problems on transformation. In your notebook, whatever you are following for doing the preparation, right? Whatever we have learned, just that is a takeaway from a concept point of view. I would want you guys to solve few problems by yourself and bring few problems to the next class. When you come to the next class, right, you will say, okay sir, we tried few problems. These are 2 problems that I want you to solve for us. Okay? So that way, what you are going to do is, you have your own magic for solving problems. And I will also try solving some problems, the ones that you guys bring. And then we'll see which one is a better bet. It might so happen that you guys have a better idea of solving problems in a much quicker and faster way. Or it might so happen that I probably had a better idea there. You will pick the best that works for you. Right? That gives you guys more options. And that is why I also encourage you guys to talk to each other. When you solve a few problems on the topic that we learned in the class, talk to each other, solve a problem. Oh, did you try this one? This is how I am doing it. Do you have a better way? Trust me, friends make a lot of magical difference into our lives. There is one formula, I'll give you this example, of potash alum. Okay? And the chemical formula for that is K2SO4, Al2SO4, both 3, 24H2O. This is potash alum, this is a chemical compound. Okay? and I didn't know about this formula. The example that I'm giving you, I mean, in my 10th grade, I would say, we were like 4 or 5 kids who were having very fierce competition among ourselves. There'll be a very thin margin by which somebody gets first rank, somebody gets second rank, third rank, fourth rank in the class. So we were in top 5. This formula I didn't know, and I had the fear, the exam this one came. I had not come across this one before. And one of my best friends who was sitting next to him, sat next to me in the examination hall, I'm not supposed to do that. I said, do you know the formula of this guy? Yeah, he just told me that in the examination hall. And that's the only time I have come across this formula, and I remember it after 40 years now. Because this came from my friend. When you discuss things with your friends, you will. I mean, I was not supposed to ask this question to him in the examination hall, but what I'm saying is, when you discuss things with your friends, you retain a lot. So that's why I would encourage you guys to practice few problems, exchange with each other, and bring some problems to the classroom, and then we'll see if the teacher has a good idea or you guys are already equipped to solve things by yourself. Okay? Now, we will go to the next topic, which is about finding out volume and surface area of 3D objects. Volume and surface area of 3D objects. What is that you guys already know, and I'm just trying to figure it out so that I would know from where to start. It's okay.
I don't know what I'm supposed to say.
I'm sorry, Vita?
I don't know what I'm supposed to say.
Okay, so
I know what volume and surface area is, but I don't know what word.
okay, and this is in the syllabus for sure for this exam, right?
Yeah.
Yeah. Okay. Now,
Let me learn this.
I'm sorry, Vita?
Let me learn about volume and surface area.
You guys have learned about it.
Yeah.
So let's say, what are the commonly used 3D objects that you have come across?
Rectangular prism.
Okay. What else?
Cylinders?
Cylinders. Okay. What else?
Spheres.
Say that again.
Spheres.
Spheres. Okay.
Cones.
Cones. Okay. See, you guys are giving me a lot of what do you call it? Extra energy boosters, which will get me started. What else? Okay, now what is that you know about guide cylinder? And again, I'm not trying to put you guys on the spot, I'm just trying to extract as much information to enable myself to know the starting point. Yeah.
Sorry, I need a question. No, about. Wait.
What is rectangular prism?
A rectangle?
Rectangular prism.
Rectangular prism? Like about the volume?
What is it? Let's forget about volume, surface area, everything. Tell me, describe a rectangular prism, assuming I'm a 5th grader.
It's a 3D rectangle. It has four like alike sides, and then 2 squares on either side.
Okay. Anything else? Okay. Now here's the thing. All the 3D objects that we talk about. So 3 comes after 2. Right? So far we have been dealing with 2 dimensions. Meaning, so far we saw triangle, rectangle, trapezoid, cone, trapezoid, diamond, kite, whatever. Everything was fitting in these 2 dimensions. Two dimensions. When I say 2 dimensions, meaning within the boundary of x and y axis. In the coordinate plane, I was able to draw it. Why? Because these shapes had only the length aspect and the width aspect to it. Again, I mean, you'll argue saying, okay, where is length and width here? But at least I can still imagine this. Okay, if I treat x as a length and this as a height or width, I can still fit in a circle within this boundary. Yeah, they have different property. But or a rectangle. This was a rectangle. So far, this was a rectangle, as you can see, with a front view. I was getting a little playful. What I did was, I found out hundreds of rectangles of the same size. I stacked them one after another. What happened? I have one rectangle before, now I have so many rectangles stacked on the top of each other. and if I have 500 more rectangles of the same size, you will see this starts getting thicker or taller. So basically, when you are starting this object of the same size one after another, you are adding height to it. Earlier you were able to paste this rectangle on the wall or on the board. Now you are not able to, because you cannot keep it like this. I need a box for keeping it because it has height. So you have length and width. Now you have another dimension called height. This is the third dimension that came into existence. That is why it is called 3D object. Length, one dimension. Width, second dimension. And height, third dimension. If you only want to, let's say you are taking my picture here and try to paste my picture on the board, you can do it. But you cannot get me glued on this board, because this board doesn't have height to it. It's not a container which can accommodate my height. Anybody's height, even a toddler's height, it cannot accommodate. This doesn't have height. It has only 2 dimensions. So that's why you need a box. That is what, when you have shapes which have measurement along the horizontal axis and vertical axis, and the vertical axis, x and y axis, and another dimension for height, that's why it's called 3D objects. So any shape, any object which has height to it, okay, that is called 3D object. So you guys would have seen movies where you see the movie on the screen, but when you watch a 3D movie, what happens? You see the objects flying around. It looks like, it helps you simulate that you're not looking it on the screen. People are moving around, you're seeing the heroes standing next to you with the 3D glasses. Because it projects the height part of it. That's why it's called 3D object, 3D movie. Now, so summary of the blabber that I have done so far is that you had simple objects and you added height to them. You had a rectangle, you added height to it. You had a square, you added height to it. You had a circle. Circle is here. Same size circle you kept on stacking. The bangles that you would have seen mommy wearing this. All the bangles, if you put them together, it will look like a cylinder actually. And assuming it's only one person's bangles. You don't get the bangles, collect the bangles from the entire neighborhood and then you try stacking them, it will look like a weird cylinder. Yeah. So we are talking about same size shape being stacked one after another to add height to it. And that gives birth to 3D object. When you are having a rectangle, this was the rectangle in the base, and you kept stacking so many rectangles one after another. This is called rectangular prism or cuboid. Rectangular prism or cuboid. This is called a cube. You had a square as a base. You added height to it, so much so that the height is same as the side. Because the square have both the sides same, right? All length and width both same. Your height is also same as your side of the square, base square. This is called cube. That's what, see, I have story for everything. So that's why I was asking you, what is that you know about it? So if somebody comes to me and say, okay, what is cylinder? Alright, cylinder. I'll say cylinder is actually made of small circles. When the same size circles are stacked one after another to add height to it. And then I'll put this one. So I'm very clear with respect to picturizing this object in my mind. And then all the maths related to it, we'll talk about it. Okay? So when I'm talking about cube, this is the property that I need to be aware of. Then when I come to this right cylinder, my base is a circle and I kept stacking it. This is my height. Okay. Now you guys talked about a cone. What is a cone? I had a right cylinder, what I did was I found the center of the top of the circle and this part and this part I peeled off. What I'm left with is this, a cone or a funnel that you would have seen mommy using for pouring liquid into a bottle with a narrow this thing. So everywhere when you cut it, what you will see is a circle. These are circles being stacked one after another, where the radius of the circle is continuously decreasing to come to almost zero. Yeah. So this is what we are seeing. Now here in this right cylinder, whatever piece you have taken out, you can roll it to become another cone. This side will become another cone, this side will become another cone. So essentially, if you are looking at volume of this guy is made of 3 cones. This cone one side, one cone in the middle, and this is another cone. So volume of this guy, whatever it is, it will be 1/3 of this volume. So far not disclosed what the volume is. I am not even told you guys how to find it out. But so far with the shapes you are comfortable. Now think of a sphere. A sphere is what? This is a semicircle, okay? You glue, I'm not sure if you guys have seen the hand fan. When we were small, we used to have a stick attached to a rectangular or circular thing, and we'll rotate it. Yeah? This sphere is nothing but that small hand fan, okay? Which is made of semicircle, and when you rotate it by 360 degree, it forms the sphere. Okay? So far we have just looked at what are these shapes and what are the properties of these shapes that we need to be aware of. And that is the most important thing, even more important than the formulas of what you are supposed to. Because if you are clear about the shapes and the properties, you will be able to decode it like this. Now let's see. Now let me give you guys one simple clue. You had this rectangle. If somebody asked you to find out the area of the rectangle and times width, no problem. Only thing that changed for you was height. More the height, bigger it gets, more space it needs. The space any object takes, that is what is the volume, right? So whatever you had as an area, multiply that with the height. That becomes your volume. If I come to this guy, what I will do is I look at volume. So there's one generic formula that I will use for many of the shapes, many of the objects. Let's go step by step. If I am talking about volume of this guy, I'll find out area of the base. One other side, okay? Be it this as a base or be it this as a base. I'm using this as a base because I know this is my length, this is my width, and this is my height. Okay? I'll find out the area of the base. My base is nothing but a rectangle. So volume of this guy is area of the base into height. And this becomes a generic formula for most of the simple 3D objects. Now let's look at it. What is the area of base here? Area of the base is length into width. Multiply that with the height. This is the volume. Okay? I don't need to worry about what is the formula times width times height. I don't need to remember that. I would see, okay, is this a symmetric object, meaning here to here top, same? Okay, wonderful. I'll find out the area of the base, multiply that by height. Come to this guy. Again, same thing. What is the volume? I'll say area of the base times height because it's symmetric. It's not changing dimension, right? What is the area of the base? My base is nothing but a square. So length and width both are same. Length into length. Times height. Interesting. That is also same. Yeah. Now you come to cylinder. Thankfully this is also symmetric. Okay. So if you have to find out the volume of this guy, what I'll do? Find out the area of the base. Area of a circle is pi r square. So here volume is area of the base pi r square. This is the area of the circle. Are you memorizing formula? No. I'm just, see, volume of a rectangular prism is length times width times height, volume of a cube is length into length, volume of a cylinder is pi r square h. Good, if you remember it, it's very easy. If you don't remember it, that's even better. Because you will, see, if you come to the class 3-4 times, you will remember my face, my name. I will remember your face, your name, no question about it. Even if I'm getting older, I'll still remember it, right? So, what I'm trying to say here is, you remember these shapes. This is what you have seen. Okay? You're okay with it, right? Okay. When you're looking at these shapes, you remember the property of the shape. You will never assume me to be 6'5" tall, right? You know, I'm this tall only. Yeah? So here also, you know the property of these shapes. That you will not forget. You will never think that, okay, a cylinder looks like this. Cylinder will never look like this. Yeah? So that you will not forget. You might forget the formula. What I'm saying is, as long as you remember the property, you'll say, okay, fine. Area, volume of any symmetric object, 3D object is, you find out the area of the base times height, that's it. You can remember it or you can derive it. Deriving it also will not take time because you'll say, okay, volume is area of the base pi r square circle times height. Okay, it takes just 5 seconds. Well, if you just by chance you forgot the formula and then you're scrambling to recall it, you might end up taking 30-40 seconds to recall it, depending on your memory power. Okay? But you can derive it in 5 seconds. Why you have to stress out? Yeah? Are you guys okay so far? So volume of rectangular prism, cube and right cylinder we saw. What about surface area? How do you find out surface area for cube or cuboid or a right cylinder? Now you will see me doing some drama. Okay, let's see. How will you find it out?
Find the area of all the surface.
Okay, but how? What is that you're relating now? See,
You take the area of all the sides and you add them together.
right, but is there a shortcut to it?
You times the area of the base times 2, and then you have the area of the sides times 4.
No, not area of the side times 4. See now let's look at an even simpler way. What do you see? The top area and the bottom area are same. So I have a pair of same area. This side and this side are also the same. This is another second pair of same area. The front and the back are the same. This is a third pair of same area. So what your goal would be, find out this one, multiply by 2, find out this one, multiply by 2, find out this one or this one, multiply by 2. So what you have is surface area. Again, I am not trying to force you guys to memorize this, but we are just deriving it now. So let's say if I am talking about surface area of the cuboid. So I am saying front one and back one same, this one same, top and bottom same. So 2 times of, let's say front one first. Front one is a rectangle. The area of this guy would be what? This is my length and this is my width, which is height. Length times height. This is the rectangle, right? This is height, this is height, this is also height, this is also height. If this is length, this is length, this is length, and this side is length. Okay? Are you guys with me or I'm forcing you guys to believe it?
No.
Alright. Okay. If this is W, this length will be same as W, this length will be same as W, this length will be same as W. So when I'm looking at the front side, for me it's a rectangle, this is my length and this is my width, which has a value of h. So length times h. Now front one is done, I'm just marking this one, front and back are done. Now coming to this guy. This is also a rectangle for me, where if this is length, this is width. So this one is also done. 2 times of this times this gives me the area of this guy. I got this side and this side also. Now coming to the top, this is also a rectangle for me, where this side is length, which is same as L, and this side is width, which is W. So this becomes your formula for surface area, which is 2 times of length times width plus width times height plus length times width. Or width. Length times height, width times height, length times width. Unique combination, length and h one combination, h and w another combination, length and w another combination. If you have to find out the surface area of this guy, this should be easy. Because you have 6 sides. It's a dice that you are rolling, that you can roll. I mean, like, you guys play snake and ladders. Yeah. So you would have seen 6 sides, all are perfect square, same size, because all the dimensions are same. So any square that you look at is same here. So the surface area here would be 6 times area of one of the square, which is length into length. That's it. So I'm totally against the idea of forcing my kids to memorize formulas. Okay? That's why I'm doing all this blabber to make sure that you guys are able to relate to it and then apply it. Okay? In the examination hall, if you have to deal with something, you don't have to scramble to figure out, okay, what was the formula for this guy? That should be the last thing. You'll say, okay, fine, this is the object I'm talking about. What is that I see here? Okay, I have 2 sides, these 2 sides and these 2 sides. Okay, easy. What you will end up memorizing is only the formula for the basic shapes, like area of a rectangle. That you anyways know, you'll not forget it, at least for next 20 years. You'll not forget the formula for area of a rectangle, right? Yeah. Similarly for square also you'll not forget. Circle also you have memorized by now. So as long as you remember that much, it should be okay. Now let's come to, so we saw how to find out volume and surface area for cuboid and a cube. How about the cylinder? How will you find out the surface of the cylinder? This is interesting.
You take the circumference of the base and you times that.
Circumference of the base times height. I'll have to do some drama.
Yeah, unwrap the cylinder.
Wonderful. You are spot on. This is one thing that I do to help kids visualize it. Okay? So this is my cylinder. Okay. If somebody says find out the surface area of this one, imagine this is a solid one. Okay, this is not the hollow one. Somebody says find out the surface area of this guy. My first lookout would be, okay, it has 2 things. I see circle here, and then I see this curved surface. So I have to find out the area of the circle, area of this circle. Okay, area of the circle, if I am given the cylinder, I know the radius of this guy anyways, right? So I have 2 circles of the same size, so 2 times pi r squared. This is my area of one circle, multiplying that by 2. I have taken care of the top and bottom. How about this curved surface? So now if you look at it, this is your circumference. When you cut it open, when you look at this curved surface, right, you are cutting it open along the perimeter of this guy, like what Ahana was saying. Your circumference opened to become a side of the rectangle, which is same as 2 pi r. Your circumference is 2 pi r. That 2 pi r became one of the side of the rectangle, and height is the second side. This is your height. So now when I open it, 2 pi r opens up to become one side, and this is your height. So curved surface is 2 pi r into h. So 2 pi r squared plus 2 pi r h. This becomes your surface area. So you will say surface area of a cylinder is 2 pi r is common, 2 pi r is common. So this here you have an extra r, and here you have an extra h. That's it. So I'm not asking you to memorize it again. I'm saying be a little destructive to imagine this. This was a cylinder, this was one circle, this was one circle. These 2 are 2 surfaces, 2 pi r squared, and then you are looking at this curved surface. You said, okay, how do I get to measure the entire curved surface? This curved surface is falling along the circumference. If I cut it open along the circumference, my circumference became the side, one side of the rectangle, and this is the height. Yeah. So that's how this is 2 pi r into r plus h. Enough of torture for a day. Yeah. But the point here is, does it help you guys relate to it?
Yeah.
Yeah. Life will not remain easy. That's my guarantee. It has not remained easy for me this far. People will not say, okay, you have a cuboid, find out the volume and surface area of it. They will not say that. They will say, you know what? I'm punching a hole. Now find out the volume and surface area. So you know how to find out the volume of the cylinder. You know how to find out the volume of this rectangular prism. You'll find out that volume minus this volume gives you the volume. How about surface area now? Think about it. We'll talk about it in the next class. But I would want you guys to, on rigid, non-rigid transformation and volume of shapes. We have not talked about cone, we have not talked about spheres so far. We'll talk about those. We have not even talked about triangular prisms. We'll talk about all those. But between now and the next class, try finding some problems that you see in your sample practice papers on transformation, geometric transformation and the volume thing, and bring problems to me and let me see if I am able to do any justice with helping you guys solve that in an easier, relatable way. My only guarantee to you all would be